Hey guys, tonight we're going to be looking at quadratic functions, which you should be familiar with from Algebra 1. The function x squared, which is a parent function for quadratic functions. This is the parent. Okay. This is function notation. And so what you need to know about function notation is that the first letter is just a label. This would be function f. This could be any letter, any symbol, okay, that describes the function. So if I have more than one function, I would use a different letter to represent that function, okay? And then the letter inside is your input into the function. Okay, so x is normally what we use for our input. It could be any letter, but we will use x as our input for our function. The total notation, f of x, really represents y. Okay, so if you're plotting a point, we all know that when we plot a point, we start with the x, and then we plot the y. Okay, we could write it like this: plot the x, and then the f of x to get to the point. Okay, so y and f of x are the same, they're equal. They're different notations. Okay, and remember, it doesn't have to be f, it could be g or h or p or q or any other symbol. Okay, so let's go ahead and start by graphing this really quick. Let's choose some numbers here. I have a little arrow here in the way. Let me move it out of the way. So whenever you're going to graph a function, you want to choose some negative and positive numbers. Okay, and I like to usually choose 0 as one of my numbers because that's going to give us our y-intercept. Okay, so sometimes I will stop the video and just fill in some things. Make sure you are pausing the video if you fall behind. Make sure you are thinking about what I'm doing. So I chose these numbers, okay, and then I took those numbers and I plugged them into the function. So when I plug -2 into the function, I put it in everywhere I see an x, I put in -2, and then I squared it, and -2 squared, notice I'm using a parentheses because I want to square the negative and the 2. That would be -2 times -2, which is 4. Okay, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. If you're using a calculator to do this, be sure to use the parentheses, because a calculator, if you put it in like this, okay, your calculator is going to say it's -4. Well, you're telling the calculator that you're only squaring the 2. Okay, we want to square the -2, so we group them together using a grouping symbols using the parentheses, and that's going to give us a correct answer of 4. Okay, let's plot the points. All right, so I plotted the points, went ahead and drew my parabola, not parabola, my parabola. Here we have our vertex, which is also our x-intercept because it touches the x-axis. And it's also the y-intercept because it touches the y-axis. Remember, if a point touches an axis, it's an intercept. Okay? Remember, if I say something and I don't write it down and you think, wow, that's cool, I didn't know that, pause the video, rewind, write it down, okay? Remember, you should be thinking along with writing, pausing, and studying this as we go. And tomorrow in class, I'll answer any questions that you have over this material that you didn't understand. Graph each of the following quadratic functions on the calculator. Explain how it is different from the parent function in the lines below. So it's up to you. You have the parent right here. You could always put the parent down here if it helps you as you are comparing the two. So in class this year, we're going to be using these TI inspires, okay? And I'll try to zoom in here a little bit. When you turn it on, that's this button right here, you're going to get this screen. You're just going to press OK. And you do that with this middle button. And we're going to go ahead and we're going to use the document. So we're going to open up a new document. So number 1, we want a graph. So we're going to go to number 2. And up here in this section right here, we're going to put in the graph. So what I suggest is, since we're comparing this to the parent, let's put the parent in first. So we're going to plug in x and squared and enter. There's our parent. Now to get another graph on here, you're going to press tab. Okay, and we're going to go ahead and put in our new function. So we're going to use the negative, the x, and the square. And that should give us the function that we're going to compare to the parent. Press enter. Aha. So we want to graph it first of all. So rather than just making a sloppy sketch on here, we're going to go ahead and plot 3 points. So press Control, and then T, Control T, and we get a split screen, and it gives us our points. So, for example, in our parents, okay, 1, 1, 2, 4, well, we need the negatives as well, so we're going to go ahead and arrow up. There we go. So negative 2, 4, that's our parent. What we want to plot is the new function. So our new function is red, so we're going to use these points over here. So we got negative 2, negative 4. We've got negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4. So the words that we're looking for to compare are words like translated. And then a direction. For example, left, right, up, down. Okay? Remember, the word translated means to slide or to shift. Okay? So, but you're going to use this word here, correct vocabulary. Translated, in this case, it didn't get translated. We always go from the vertex, and the vertex is in the same place, so it wasn't translated. So if it was translated, you'd write translated, you'd write the direction, and then you would write the number. The number. How many units? Okay? Well, not translated. Another word we could look at is stretched. Okay, so stretched, if the y values are being stretched, it's going to look narrow. Narrow. Okay. Compressed. So if the y values are being decreased, okay, the graph's going to look wide or wider. Here's a picture of narrow, real narrow. Wide looks kind of like that. Okay, another option we could have here is we could have a reflection. Now reflections can go different directions. One direction, it could be across the x-axis. It could be across the y-axis. And we could be across the origin. Okay, so what do you think? Do we have a reflection here? So the parent was opening up, and now it's opening down. So another word for reflection is flip. You should remember these words from geometry, some of them anyway, translations, reflections. We're not going to do any rotations. So we have a reflection. So we're going to write using complete sentences. The parent function was reflected across the x-axis. And we can tell that also by looking at the table. All right, let's take a look at the next one. So let's go back to our graph, our calculator, and I'm going to go ahead and get rid of my table for now. So to get rid of your table, you just press Control T, okay, and the table goes away. And then we're going to go ahead and get rid of this one down here. And I think to do that, we're going to click on it, double click on it, and then we can delete. No, I'm not pressing that button, I'm pressing this button right here. Delete. There we go. And we're going to put in our new function. Okay, and we're going to graph it. Press enter. Okay, so taking a look at this one, we see that the parent, it got moved, shifted, translated, it went to the right 1, 2, 3 units, starting at the vertex. It went right 3 units, and it also got narrower. Okay, so looking at our words, we're going to use translated, and we're going to use stretched for narrow. Now I'm running out of time, so we will continue this video tomorrow night for some more practice on this, or we may finish it in class. We'll see. So make sure you have these ready in class. I will be checking them during the warm-up. I hope you're having a good night, and see you tomorrow.